Just what is music exactly? Music is a collection of sounds organized so that it has a pleasing quality to the human ear. But are all sounds musical? Some people might say so, but generally speaking, sounds that we consider musical have a particular set of traits. First though, let's talk sound. What is sound? Well, sound is a wave that travels through a medium and can be detected by the human ear. While most waves have irregular vibration patterns, some have consistent vibration to them. These waves are what most people will consider musical. When looking at a waveform, there are a few features that determine its oral qualities. The first we will look at is amplitude. All sounds have amplitude, which our ears measure as the volume of a sound. When we visually look at a wave, we can see a series of oscillations peaking and then falling. The height of these peaks is what we refer to as the amplitude. The greater the height of a peak, the louder the volume of the sound will be. Similarly, the smaller the peak is, the softer the volume of the sound will be. The second feature, and arguably the more important in regards to music, is the frequency of a sound wave. In sound, frequency refers to the number of oscillations in a wave per second. The unit we use to measure it is called hertz. In simple terms, it can be thought of as the speed of vibration. When there is a discernible frequency, we interpret it as a pitch. In music, different pitches correspond to what we call notes. Now, notes have distinct frequencies that separate them from one another. In Western music, each note's frequency is about 1.05945455 times the previous note's frequency. So as an example, the note A4 has a frequency of about 440 Hz using an equal temperament scale. The next note in chromatic sequence would be A sharp, also called B flat, that has a frequency of about 466.164 Hz. So eventually, if we keep progressing forward by the factor mentioned before, we will double our original frequency. In the example of A4, this will occur at 880 Hz, also known as A5. The result will be a frequency that, while producing the same note as 440 Hz, the pitch will sound higher. In music, we refer to this as an octave. Here I have generated the note A4 for a total of 2 seconds. As previously mentioned, A4 is 440 Hz, which translates into 440 complete oscillations per second. So in the span of these 2 seconds, there should be twice this amount, specifically 880 of them. It'll sound like this. If I were to compress this wave in only to a single second, there would now be a total of these 880 Hz in that single second instead of over 2 seconds. The result would be an octave above that A4 at A5, 880 Hz. It would sound like this. Similarly, if I took that original 2-second sample of A4 and decompressed the wave so that it lasted twice as long at 4 seconds, there would now be a frequency of those 880 oscillations total, except now over the time of 4 seconds. The result would be 220 oscillations per second, or 220 Hz, generating a lower frequency and tone. The note would be A3, and it would sound like this. But if two different instruments play the same note and produce the same frequency, then why do they sound different? Why does a piano sound like a piano and a guitar sound like a guitar? In music, we refer to this phenomenon as timbre. For example, let's use that A4 again for simplicity. What happens is that while both instruments are producing the same fundamental frequency of 440 Hz, they each produce a series of overtones, or partial frequencies that are unique to the shape and materials that the instruments are constructed with. We can look at it as though each instrument is making the same main frequency. They each have a number of minor frequencies that accompany it. This gives each instrument their characteristic sound, or timbre. Combined with their fundamental frequency, we can see that each instrument has a unique waveform in addition to their characteristic sound. So can only instruments make music? Of course not. Anything that can produce these regular waveforms with the qualities previously described can be considered musical. These can include everyday objects, or a combination of common items put together. Some examples would be something like resonating wine glasses, spoons for percussion, or a comb with a piece of paper. Get creative and combine any number of these to produce music that is as rich and interesting, or maybe even more interesting, than conventional instruments. Thank you for listening.